In the subnetting 2 video, we actually are talking about fixed line subnet mask, whereby all the different departments or all the different groups are using the same subnet, with equal number of IP addresses in every subnet. Take for example, in subnetting 2, we have actually gone through the video. We actually changed the subnet mask, from 23, to /26. And when we do that, basically, I will have actually 6 host bit, which will actually give me 2 to the power of 6, which is 64 IP. And if I minus 2 IP, which is the network address and broadcast address, I'll be having 62 usable IP address each, for each subnet. So it means that regardless of how many addresses are used by the different department, 62 IP addresses are reserved for every subnet. If you take a look at, for example, the management department, which only required 3 IP, it will actually be a huge waste of IP address, even though we have actually changed the subnet mask, split up the bigger group of subnet into smaller group of subnet masks. And this is where variable length subnet mask is much more efficient in allocation of the IP addresses to the different groups based on the most effective allocation of IP addresses. So if you still remember, for fixed line subnet mask, we are actually borrowing the host bit by extending the network bit by the number of bit in order to accommodate the different number of subnets that we want to create. But in variable subnet mask, we will actually, instead of looking at extending the host bit, we will actually need to make use of the host bit. Instead of the network bit, we need to look at host bit to determine the most efficient subnet mask to use for every single group. So before we actually start to do our variable subnet mask, one good practice will always be to rearrange the IP the different department in terms of its IP addresses from biggest to smallest. So if we were to rearrange these 5 departments starting from biggest to smallest, I will have transport, which is the biggest, followed by sales, second. Third will be finance. The fourth will be human resources. And last but not least, management only required 3 IP. So if you still remember, by looking at the number of host bit, which is the 0, we can actually determine how many IP address can I get from the host bit itself. So let's talk about our previous subnet mask 255.255.254.0, which is the /23 given. So basically 23 give us 23 bits of 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, followed by 9 bits of 0. And we know that 2 to the power of 9 will actually give me 512 addresses, including network address and broadcast address. So when we are doing variable subnet mask, you will actually need to determine the number of IP address required, based on the number of 0. So normally, instead of going from left to right, when we do variable length subnet mask, we will actually be going from right to left. Means that we'll be counting number 0 from right to left. So if I got one host bit, which basically is equivalent to decimal dotted notation 255.255.255.254, or /31, it will means that I will have 2 to the power of 1 address. So basically it will be 2 IP. But we know that in every subnet, 2 address will need to be allocated for network and broadcast. So 2 minus 2 will give me 0. So effectively /31 are normally not used for any planning of subnet. For 2 host bit, similar process. Basically it will be 255.255.255.252 or /30, which is equals to 2 to the power of 2, which will be equals to 4 IP, minus 2 will be equals to 2 usable IP. So normally a /30 is very useful when we are thinking of allocation for point-to-point link, like between routers whereby we have a serial link between them. 3 host bit. So basically you can actually generate all these different numbers of IP address requirement based on a table before you actually allocate the different requirement for the different address. So I'm going to do 1 2 3 4 5 6 12 5 6 7. So basically 252 3 bit will be 248 240 224 192 and 128. So basically it will be /29 28 27 26 25. So basically 2 to the power 2 to the power 3 4 5 6 7. So basically it will be giving me 8 16 32 64 and last but not least 128. And when we minus 2, I'll be getting 6 14 30 62 and last but not least 126. So that means that we are going to make use especially the usable addresses to determine the actual subnet mask to be used depending on the grouping. So if you're going to compare, the transport needs 60. Definitely I cannot make use of /31, which give me 0. /30 give me 2, not enough. 6 also not enough. 14, 30 also not enough. So the best subnet mask to use without sacrificing a lot of IP addresses will be a /26 subnet mask. Then when I look at the sales department, 30 cannot accommodate 48, but 62 is able to accommodate. So I'll still be using a /26. And for 28, I'll be using a /27. And for 13, I'll be using a /28. And last but not least, for 3, I'll be using a /29. So that means that for variable subnet mask, the first thing that you need to actually determine, is to actually determine, the best subnet mask to use, depending on the usable address, that you can get from the number of host bit. And from there, you can actually start to actually plan out, the network address and the usable address based on the subnet mask. So basically, we know that we need to start off with the first address, network address 10.16.32.0, which is the first address, for the transport group. And we know that we need to use a /26, subnet mask. So similar to how we make use of magic number to determine, the next address for the next subnet based on the subnet mask being used. We're going to do the same thing again. So you can see that from 23 is 24 25 26. And we can see that my new subnet mask actually ends at the bit value of 64. So it means that if the first group is using a /26, the next address will be 10.16.32.64 because I need to add 64 okay, to the previous subnet. Okay, and by looking at the next group, I'll be making use of /26 too. So it's still the same subnet. So it means that I will actually need to add another 64. Okay, so the first subnet mask I add 64 to bring me to the network address for the next group. And because the next group is still using a subnet mask of /24, I will need to add another 64 to bring me to the network address for the next group, 16.32.128. Okay, but the third group I will be using a /27. Okay, so for /27, so 26, this 27, 27, the bit value is 32. Okay, so it means that, okay, in order to get to the next network address for the next group, I will need to add 32. So in this case will be 10.16.32, okay, .160, okay, which will be the network address, okay, for the next group, which I'm going to use K27, okay, 27. So this network address that I determine will be the network address for the human resource group. Okay, and for human resource group, I'm going to make use of /28. Okay, basically I need to increase the subnet mask bit by another 1, and the place value is 16. So in order to get the network address for the next group, I will need to add 16, okay, to this network address for the fourth group. So okay, it will be 10.16.32.176. Okay, and the subnet mask to be used for this last group will be 29. Okay, and for 29, okay, basically will be, okay, this bit here. Okay, it means that, okay, in order to get the next group network address, if there's a requirement, I will need to add an 8 to it. Okay, so it's plus 8, okay, to get to the next group. 16.32 plus 8 will be 184. 184, yes, okay. But because we don't really need, okay, the network address for next group, because we only need, okay, the network address for all the different group. So we have our transport network address, human resource, finance, human resource, finance, okay, then transport, sales, finance, transport, sales, finance, human resource, and last but not least, okay, the management group. Okay, so this will be the network address, okay, for all our, okay, for all our different groups, okay, which is the first address of the group. And you still remember about, okay, fixed line subnet mask from the previous video, okay, in order to get the broadcast address, okay, of, okay, the different group, okay, I just need to minus 1 from the next subnet mask, okay, in order to get the broadcast address, okay, for the previous group, okay, or the previous subnet mask. Okay, and this will also allow me to calculate the range of usable address. So that means that for transport, okay, for transport, okay, the broadcast address, BROADCST, okay. So in order to get the broadcast address for the transport group, okay, we will need to look at the next subnet group, okay, network address, okay, which in this case will be the sales, okay, which have a network address of 10.16.0.64 minus 1, which will give me 63, okay, which will be the broadcast address, okay, for the transport group. So similarly, okay, for the sales department broadcast address, okay, I look at the next sub network address for the next group, which is 128 minus 1. It means that, okay, the sales broadcast address will be 127. And since we have our network address and our broadcast address, so we will be able to actually determine the range of usable IP. Okay, and in this case for transport department will be from 1 all the way to 62 because network address +1 and okay, broadcast address -1. And for the sales department, okay, it will be from usable IP will be from 65 all the way to 126. Okay, and basically you just need to repeat this process for all the other departments. And this is how you can actually derive okay all the necessary IP addresses making use of variable length subnet mask. Okay, before you can use the range of user IP to assign the IP addresses to all the end devices such as your computers, the interface on the switch, or the interface on the router.